First option in a limit problem is to try direct substitution. Well, when I do direct substitution, I get the square root of 6 minus the square root of 6 over 0, which, oh boy, it gives us this indeterminate form. We've learned plan B, after plan A fails, direct substitution fails, we learned plan B could be make a table and check out the trend in Y as you squeeze in on x equals 0 from both sides, remember. We learned you could make a graph and just look at the graph and say, where is Y trending toward as x squeezes in on 0 from both sides? We learned if you have some polynomials, you might want to do factor, cancel, and then direct substitution. If you have a complex fraction, a over b over c over d, you could try to combine the fractions and then cancel and then use direct substitution. Whenever I have a radical, I think introduce conjugates. Now, if I have a plus b, the conjugate I'll introduce is a minus b. What's nice about conjugates? Well, when you FOIL them, the OI of FOIL disappears, and all we have to worry about are first and last. Let's take a look. For any two conjugates, I'm saying a general case, first times first is a squared. Last times last is minus b squared. And here's where the magic happens. The OI of FOIL, outer and inner, gives us minus ab plus ab. Notice those will cancel, and we're left with a difference of perfect squares. Now, if I had a minus b and I introduced a plus b, I'd still wind up with the same answer. So there's no big deal about order if the plus is first and the minus is second, or the minus is first and the plus is second. Notice first terms are equal and second terms are equal. The only thing that's different in conjugates is the sign between the terms of each of the binomials. So when we see radicals, think conjugates. If my numerator is the square root of 6 minus x minus the square root of 6, I am going to introduce its conjugate. Playing the role of a is the square root of 6 minus x. Playing the role of b is the square root of 6. Now, if the sign in the middle is negative, the conjugate will have a positive. And I'll be multiplying that to do FOIL. But I can't just randomly introduce square root of 6 minus x plus the square root of 6, but I can introduce a fraction equal to 1. So if I mirror this on the bottom, notice it has to be exactly the same, including the plus sign, because this full fraction that I just introduced is a fraction equal to 1. So I haven't changed anything. I can multiply by 1 without changing anything. All right, let's go to work. This is going to be the limit as x approaches 0 of, well, this is the square root of 6 minus x times the square root of 6 minus x, which will give us the square root of 6 minus x squared. Hopefully you can see the square root and the square will undo each other. So what we really get here is 6 minus x. The last term, remember, I don't have to worry about, if I'm foiling this, I don't have to worry about the OI of FOIL because they are conjugates. In the last terms, I get minus times plus is minus, and I'll get the square root of 6 times 6, which is the square root of 6 squared. Well, the square root and the square, you can think of them as undoing each other, and we're just going to wind up with whatever's under the radical there, 6. And in the denominator, I'm just going to keep this as x times the square root of 6 minus x plus the square root of 6. You could distribute that if you want, but maybe you'll be able to cancel something out. So I try to keep that separate so that I can cancel if necessary. Well, speaking of canceling, if these 6 have been good little 6s, they go off to number heaven, and we're left with the limit as x approaches 0 of the opposite of x over x times the square root of 6 minus x plus the square root of 6. This is exactly why I didn't distribute this. Because if I have a times b over a, I can cancel those. I have multiplication here in the denominator, which allows me to cancel these. Now, it's going to be 1 over 1. They don't cancel to 0. So I'm left with limit x approaches 0 of the opposite of 1 over the square root of 6 minus x plus the square root of 6. And now, after I've canceled, I can do my direct substitution, which gives me negative 1 over the square root of 6 minus 0 plus the square root of 6. Well, there's 2 of them. So we can say this is negative 1 over 2 of these square roots of 6. And there is our limit. It's the y value that our graph is trending towards. By the way, here I knew there was a hole. What's the hole? Well, x is heading towards 0 as y is heading to negative 1 over 2 root 6. So that's bonus. That's not part of the question, but I just want you to understand. We're taking the limit at a hole. As soon as we saw that, we knew this is true.